Okay, hello 2Ps. Welcome back to math. I hope you're all doing well. I will be posting lessons and announcements on Brightspace, so please be checking our Brightspace page regularly. Probably every day because I'm not exactly going to be posting things on a regular schedule. I will try, but we will see. My plan is to post 2 or 3 lessons a week. Each lesson will consist of a little video lesson. I'll go through some examples with solutions. I'll give you some practice questions to try that you can also have the answers for so you can make sure you're doing them okay. And then at the end of each lesson, there's going to be a really quick, like 2 or 3 second little quiz. Those will be for marks, and it's just so I can see how you're doing with the material. The first thing I want you to do, though, is hand in that last assignment that we were working on before the break. I believe it was called the linear relations assignment, and you can find that on Brightspace. I have sent it out to your parents as well. I do have some of your assignments already, so if you handed them in on paper, that's great. Thank you very much. If you're not sure if you handed it in already, just give me an email or an instant message on Brightspace and I can let you know. If you're having troubles finding it, please let me know that as well. The best way for you guys to contact me throughout this whole online process is to go to Brightspace, click on the envelope in the top right corner, and you can either instant message me or you can send me an email through there. Okay, so this is going to be our last lesson of the linear equations and relations unit, unit 2. So I've put a blank copy of this document up on Brightspace. So if you want to print it out and fill it in with me as I fill it in, you can. If you don't want to fill that out, that's okay. I would definitely make sure that you're writing this information down, maybe on your own summary sheet. That way, when we come back to this stuff later on in the school year, you'll be able to refer back to this sheet. It is 2 pages, so this video might take a little longer because your second unit was a lot longer than the other students' unit. So hopefully we can get through this quickly. So at the top, I have a bunch of definitions you should be familiar with. So let's just go ahead and write some of these down. So what is the rate of change? What is the slope? Well, there's lots of things you can write there. You might want to write that that's m in the equation. Okay. You can also write down that, hey, that's the multiplier, isn't it? The multiplier. So that's going to be the number in front of the letter. So number in front of, and we call those letters variables. So I'm going to put variable there. Initial value, y-intercept, well, that's known as your b value in our equation. This is also the starting point, isn't it? That's the starting point. This is the constant in the equation, so the number that's all by itself. If you want to draw a little graph, you can. If there's a, say that's our, our coordinate axes, and we have this linear line, our initial value, our y-intercept, that's where it goes through the y-axis. So right there, right? First differences, well, if we do a table of values, and we're going to do some examples on the back. So let's have, 202 or something. And let's make up a number. Let's say it's 135. Remember, our first differences are if you do your bottom number minus your top one, that's 2. 5 minus 3 is 2. And remember, these should be the same if it's linear. So if they're the same, it means it's linear. Okay. A best fit line, we haven't really done this specifically, but if you have a grid and you have a bunch of points, your best fit line is something that's going to go through basically the middle of those points. It may not touch all of the points. It doesn't have to touch any of the point actually, but it kind of gives you an idea of the what's the word I'm looking for? The direction of the data, where it's going in. Don't worry too much about that one. I just wanted you to hear that. You won't be doing much with it in this class. Rise and run. Well, let's draw a diagram here. Right? So if we have a linear line here, and let's say we're trying to find the slope, well, remember, we can take any 2 points on that line, and your rise is how far does it, how far does it go up by? And then your run is how much does it go from left to right, so that distance. And remember, rise you can find from y2 minus y1. If this was your point 1, so this will, point 2, so this will be your x2, y2. And this point here will be your x1, y1. This point right here. So your rise is finding by subtracting your y2 minusing your y1, while your run is x2 minus x1. And that's also another way we can find the slope, can't we? Linear, well, that means straight line. That's all that means, that the line is straight. Straight line. Y equals mx plus b. Well, this is an equation for a straight line. Or we can call it, this is a linear equation. If a line on a graph is straight, if it's linear, it will follow a linear equation. The equation will be y equals some number times x plus another number. Horizontal lines, well, if we draw a coordinate grid here, horizontal lines are flat, so like this guy, and they have the equation y equals a number, and that number is always the y-intercept, and so where it goes through the y-axis is what that looks like. Vertical is the same thing but for x equals. So if this is our coordinate grid, we can put a line here. I'll do it dotted. Okay. Let's call this A. Since we have a B here, let's call that one A. So this is the equation for a vertical line is x equals a number. And in this case, x will equal to A, wherever that line goes through the x-axis. Parallel lines, well, if we have 2 lines that are parallel, ooh, do you think I could draw parallel lines by hand? I will try. So those are parallel. How can we tell if they're parallel by not looking at the graph? Well, they're going to have the same slope. And that's the same m values, right? Perpendicular means that the lines cross at 90 degrees. So if we have, for example, this line, perpendicular to that will be one going this way. And now how can we tell just by looking at the equation? Well, their slopes are inverse, sorry, they're negative inverses of each other. Negative inverses. So for example, if you have one slope is 3, the other slope would be 1 over 3 and make it negative. Okay. So that's a lot of information there. Okay. Ooh, sorry. Still working on my setup here. One thing I should have added here was the equations to find slope. So let's put that up here because this is really important. So remember, slope is rise over run. So your rise divided by your run, which is equal to your y2 minus y1 all over your x2 minus x1. So remember your y2 and x2 points, those are going to be the one furthest to the right, and your y1 and x1 are going to be the ones furthest to the left, okay? So now let's do some examples with this information and some of the things that we did in class. So we're going to be using this next unit, so we need to be able to do this, is to rearrange an equation into y equals mx plus b form. That means we need to get the y value all by itself on the left side and put the multiplier with the x variable and the constant on the other. So let's do that here. Well, the first thing we need to do is get this part all by itself. We need to get 3y by itself. So let's get rid of the 6x first. So because these are adding, you have to subtract 6x from both sides. Okay, 6x minus 6x, those go away. So we get 3y on this side equals to 5 minus 6x on this side. Now we need to get rid of that 3, don't we? So we're going to divide everything by 3. So 3 divided by 3 gives us 1. So that's going to cancel to 1, leaving us with just 1y on this side. 5 over 3. And then 6 divided by 3 is negative 2. I should say negative 6 divided by 3 is negative 2. So this is, we have things on the right side, but it's still not the x term first, is it? So we need to make sure we can put this here. Now, because they're adding, doesn't matter what order they go in, but just make sure you're taking the sign in front. So y is going to be negative 2x plus 5 over 3. And now we have rearranged that equation to solve for y. Okay. If you ever need to pause the video, go back, replay, obviously you can do that. That's the one benefit of doing these types of lessons, because you can stop me at any time, or you can fast forward me if you feel like I'm going too slow. So here's another rearranging equation question. It asks us to rearrange Pythagorean's theorem to solve for side A, and then solve. So that means plug in our numbers and then actually find what side A is. So remember what Pythagorean theorem is? Well, it is c squared equals a squared plus b squared, right? So we need to get a by itself. So to get a by itself, we need to get rid of the b squared. So we're going to subtract b squared from both sides. We did this already in the trigonometry unit, didn't we? So this should be familiar to you. Now we have a squared is equal to c squared minus b squared. We need to get rid of that squared, and to do that we have to square root both sides. Now remember, when you square root both sides, you have to square root the entire thing. Okay, so you're going to put a square root over the entire left side here. Now on this side, these are going to cancel, leaving us with a. So our equation is c squared minus b squared square root equals to a. You can leave it like this. If you want to have a on the left-hand side, you can. So it's a equals the square root of c squared minus b squared. That's okay too. So we have our equation. So now let's solve for our a. So our a is the square root of c squared, so 4 squared minus b squared. Oh, and not a squared, is it? Hopefully that can be erased. Okay, so a is equal to 4 squared is 4 times 4, which is 16, minus 3 squared is 9. A is equal to the square root of, so 16 minus 9 is 7. So now if you do the square root of 7, so 7 square root is 2.6. So let's put that, 2.6. So A equals 2.6. There. Okay. Okay, on the bottom here, this is the word problem. We have a taxi's cost is modeled by the formula C equals 0.25D plus 3. So C is our total cost in dollars, and D is the distance that you travel in kilometers. Okay, so if I go 5 kilometers, or if I go 4 kilometers, this would be $1 plus 3, so my total would be 5. But this is asking if my ride costs $15, what is the distance we travel? So, first of all, we write down what we know. So our cost is 15, and we're trying to find our distance. So we're going to plug in our numbers. So 15 equals 0.25D plus 3. So we need to get D by itself, so we have to get rid of the 3 first. We're going to subtract 3 from both sides. 15 minus 3 is 12 equals 0.25D. 3 minus 3 goes away. Now we got 12 equals 0.25D. So to get rid of this 0.25, we have to divide by 0.25 on each side because the 0.25 is multiplying the D. Remember, we have to do the opposite to get rid of it. So 12 divided by 0.25, 12 divided by 0.25, put that into your calculator, gives you 48. So 48 equals to, well, just D, because 0.25 divided by 0.25 is 1, so those basically cancel out. So 48D. So remember, with word problems, we need to write therefore statements. So therefore, the distance I traveled, or we, however you want to say that, was 48, well, remember, it was kilometers. So don't forget your units there. I don't mind if you don't put your units there, but please make sure you have them in your final statement. Okay, if you wanted to pause the video now, this would be a good time to take a bit of a break because we've done that front page. And if you want, you can go ahead and try the back and then come back and see if you answered it correctly. And I'm also going to take pictures of my solutions and put them up as a filled document, so you don't even have to watch this video if you don't want to. Okay, so I'm going to do this question next. Determine if a table of values is linear. Well, remember, when we were looking at table of values, for it to be linear, the first differences have to be the same. So let's check out what our first differences are. So remember, you always do the bottom one minus the top. So 20 minus 10 is 10. 30 minus 20 is 10 again. And then 40 minus 30 is 10 again. So this is linear. So check mark linear because those first differences are the same. If you want, you can say first diffs are the same. Okay, now let's check this bottom one. Well, 1 minus 0 is 1. 4 minus 1 is 3. Well, those are already different, aren't they? So chances are this is going to be not linear. 9 minus 4 is 5. So this is not linear. First differences aren't the same. Not equal. Okay? So that's how you can figure out if a table of values is linear or not. Calculate the first differences. Okay, graph a line with a slope and y-intercept. So the slope is 3/4 and the y-intercept is +1. So your first step here, the first step is to plot the y-intercept. So y-intercept is +1, so that's going to be right there. And the second step is to use the slope to find a second point. So use slope for second point. So this isn't a fraction, so that tells us the rise is 3 and the run is 4. Okay, so I'm going to write that down here. So slope is 3 or 4. This is the rise, and this is the run. So if my rise is 3, I'm going to go up by 3. 1, 2, 3. And from that point, I'm going to go over by 4. So 1, 2, 3. I'm going to go to the right by 4. 1, 2, 3, 4. There's my second point. The nice thing about lines is that you only need 2 points to draw a straight line. I'm going to use my phone because I didn't come with a ruler, so just use whatever straight surface you have available. Draw your straight line. Don't forget to put arrows on the ends. There you go. That's how you graph a line when you're told what the slope and y-intercept is. We got 2 more questions to do, and this is finding the equation given some information. So this one, we're given 2 points. We have to find the equation. So your first step is to find the slope. Okay, remember we wrote our slope equations up here. Well, we have 2 points which with its x's and y's, so we can use that formula. So slope is y2 minus y1, x2 minus x1. So this is the first point, so I'm going to call this x1 and y1, and this is x2 and y2. So slope is going to be y2, which is my 9, minus my y1. So minus, and then plug your number in. Be careful with signs here, okay? x2 is -2 minus x1, which is 2. So 9 minus -1, that's the same as doing 9 plus 1, so that's 10. -2 minus 2, so -2, now I'm going to go further into the negatives by 2, is -4. So remember, we can reduce this, right? They're both divisible by 2. So if I divide that by 2, it's 5/2. If you have a negative in the denominator, you can bring it up into the numerator. Okay, now we have our slope. We have to use that and one of our points to find our y-intercept. So find B using slope and 1 point. So remember, I'm probably going to go down here. Remember, our equation for linear functions is y equals mx plus b. Well, we have m, so let's put m in. Now, we don't have y, we don't have x, we don't have b, but we can get an x and a y because we have 2 points, don't we? So you can choose either one of the points. It doesn't matter which one. You're going to put your x value in for x down here and your y in for y. So I'm going to choose this point. Doesn't matter which one. So my y is -1 equals -5 over 2. And my x is 2. And now we're just left with finding b. So let's do any math here that we can without rearranging anything. So -5 over 2 times 2, well, these 2's will cancel out, leaving me with -5. So -5 plus b. Now we need to get the b by itself. So we're going to add 5 to both sides, leaving me with 4 equals b. Great, so now we have our slope and we have our b. So therefore, this equation for this line is -5 halves x plus 4. There. Okay, last question. Given the slope and a point, find the equation of a line. Well, we're going to do the exact same thing we did here, but guess what? We don't need to do step 1 because we already know what the slope is. So we just need to do step 2 to find our b value. Where's my pencil? My b value. Okay, so we're going to find b using slope and point. Okay, so again, we'll start with y equals mx plus b. And now we're going to sub in our information. Remember, this is x and this is y. So our y is going to be 3. Our slope, our m, is going to be 3. Our x is going to be 1. And then our b is left over. Now you can multiply m and x here. So our 3 and 1 is 3 plus b. So to get b by itself, we need to subtract 3 both sides. Oh, look at this. That's fun. So b is 0. So therefore, our equation is y equals m, our slope, ours is 3, x plus our y-intercept is 0. If you write it like this, that's fine. But to be 100% complete, you can just get rid of that 0, and our final equation would be y equals 3 times x. Okay, and that is everything you have learned in this unit, our very, very long unit. I hope that was a nice summary for you. You do not have a quiz for this lesson because I do want you to get that last assignment done. Okay, guys, until next time, stay safe and I'll talk to you soon. Bye-bye.